Hello class, Dr. Church, and we studied the last unit about electrostatic charge, about where electric charge comes from, some of its actions. But let's move on to something that's probably a little more applicable and interesting for you, something that you use every single day, and that's electricity and electrical circuits. Electric current and Ohm's law, title of our section today. I'll have a little simulation activity that you can work on, which I think is pretty fun. Let's talk about what is electric current. Well, electric current is the continuous flow of electric charge. We know that that's the movement of electrons. We know that within an element, electrons can be passed, protons are not. Okay, we know that the protons determine the element, but electric charge can be passed through the passing of electrons. The unit of current is the amp, the ampere, or the amp, and that's just denoted by A. It is the flow of electric charge. You're using a computer right now, looking at a computer screen or an iPad, and that is at the low level. That's the flow of electric charge. There are two types of electric charge. The type that comes out of a battery, that's called direct current, and the charge there only flows in one direction. It's direct. And then there's the alternating current, which is the type that's coming out of your outlet at your home. That is where the flow of charge reverses direction. Now that's very odd thing to think about. You would think of charge only flowing in one direction, but alternating current will flow back and forth in two directions, but is still able to provide power and electric current flow. Now let's look at the just a couple of terms here: conductors and resistors. Well, what is a conductor? It's really any material through which charge can flow, and the main one there is metal. I think we studied previously that in metal has what's called an electron C, and those are electrons that are shaped, that are free within the type of metals that are able to be passed very easily, and that's what makes metal a good conductor. A material that can pass electrons easily will allow electric charge to flow because it is just the movement of electrons. So that all makes sense. Insulators are materials where electrons do not flow easily, and that's things like plastic or rubber or wood, because there's no free ions, and what that is those um, atomic structures are very stable. Those electrons are in those stable shells that we talked about before, and so there's not flow does sorry, electrons do not flow easily, and so the electrical current does not flow easily, and so we call those insulators. Materials have what's called resistance to electrical flow. Now, if you think about that for a second, then insulators are going to have a high resistance to flow, and conductors would have a low resistance to flow. All right. But also the shape of the material will allow it to flow better. The thickness, length, and then the temperature. And we haven't studied this, but if we looked at superconductors, if you get a conductor, certain types of conductors, if you lower the temperature that near absolute zero, that they become what's called superconductors, and the electrical resistance goes to almost zero, and electrical charge will flow very, very easily. Now, what pushes electric charge along? What causes it to flow? Well, what we call that is voltage. Charge does not flow without an energy source, and voltage really is defined by the potential difference, the electrical potential difference between two fields, electric fields. So voltage is the same thing as potential difference. A battery is measured in volts. Just a small battery like a AAA battery, that's going to be like 1.5 volts, fairly small. A 9-volt battery, which you're all familiar with, that's a 9-volt potential difference. The battery in your car is a 12-volt system, and it'll deliver quite a bit of current. Some voltage sources, batteries, which we've talked about, solar panels, generators, and then of course electric current, which is generated through power plants by the power company, is providing the current and electrical potential to your home. Well, Ohm's law is a fairly simple law, and it defines the voltage, current, and amps and resistance within a circuit, and we can actually calculate the current or resistance if we know the voltage. We can calculate the current if we know voltage and resistance. If we know resistance and voltage, then we can calculate the current. And really just what I wanted you to see here is that as voltage increases, current increases, because as potential goes up, then the ability to push electrical current along goes up. So that's just a pretty simple relationship that we have there, but one that's very, very important in electrical system design and in many other applications. Well, I hope you've learned just a little bit about electrical circuits today. Just Ohm's law, what is voltage, what is current, what is resistance, what's an insulator, what is a conductor. These are all terms that you would need to be familiar with. And I think even in just regular applications of life as you go along, understanding how these work, within your home and how electrical systems work is very, very important for you. So I hope you've learned something today. Enjoy the lesson. Have a good one.